Alright, in this video we're going to compare the long-term behavior of power functions and exponential functions. So what I'll do is just go here to this Desmos file and look at some graphs. Alright, so I've already got graphed the exponential function 5 to the x, that's the orange one, and the power function x to the 5th, that's the purple one. And currently we're viewing the x values between -1 and 3. So very modestly sized x values. Initially what we can see is that the exponential function, 5 to the x, has larger outputs than the power function x to the 5th. Okay, but our goal here is to explore the long-term behavior of the function, not the short-term behavior. What we're looking at here is really more short-term behavior because it's where the x values are small. Long-term behavior is when the x values are extremely large or are large. Okay, so what we want to do is kind of zoom back and see what this graph looks like from farther away. So what I can do is come into the sort of window of our graph, the values that'll set the size of the graph paper, essentially where the graph is drawn, and increase these values a little. So I can make my x values go way out to 10, and then increase the y values maybe till 50. And as we see there, previously, remember that here in this the small x value area, the orange graph was above the purple graph, so the exponential function was on top. It had bigger outputs than the power function. But here suddenly at what it looks like 1.765, this x coordinate here, 1.765. When x's are that size, or x gets bigger than that, suddenly the purple graph has larger outputs than the orange graph. And remember, the purple graph is a power function and the orange graph is an exponential function. So at some point here, the power function starts having the larger outputs instead of the exponential function. But we're still not really looking at long-term behavior yet. Long-term behavior is when the x values are much bigger than 1.765. So we want to zoom out some more. So initially I think I just need to go up so we can see what's happening in higher y values. So change the y value to go up to 500 and then even 5,000. And look at that, there's another intersection for these graphs. Maybe I can make the window a little bit better so we can see what our x values are. And it's really only at 5. Still arguably a pretty small x value. At that point, when x is 5, the orange graph overtakes the purple graph and starts having larger outputs. And it turns out that from here on, everything bigger than 5, the orange graph will always be on top of the purple graph. Then we can kind of zoom out a little bit further. So now I'm letting the x values go to 25. It turns out that 25 is a pretty large x value in this case. It's a long-term behavior, and I'll let the y values get bigger. I'm just adding zeros to this this number to see the graph in the really long run. And you can see when we zoom pretty far out, like imagine we're standing on Mars looking down on this graph that's drawn on Earth. It's really far away and we can just get kind of a general sense of what's going on. The orange graph is it's growing much more quickly than the purple graph. And this will lead us to draw the conclusion that when exponential and power functions are both positive and increasing, the exponential ones end up growing much more quickly than the power functions in the long term. We notice when the x values weren't especially large, the purple graph had the ability to stay larger than the orange graph. The power function had larger outputs when the x values were modestly sized. But once the x values got big, the orange graph started dominating the purple graph. The exponential function dominated the power function. And let's do one last thing here. Let's compare the power function x to the fifth now with a different exponential function, 2 to the x. I think what I should do is return back to our starting spot so that we have that same initial scenario, and I'll hide 5 to the x and open 2 to the x, a different exponential function. Now, since the base is 2 instead of 5, this exponential function grows much more slowly than 5 to the x did. And you see that when we're here in these kind of modestly sized x values, the purple graph starts taking off and getting growing much more quickly than the red graph. That x to the fifth, the power function, is growing much more quickly than the exponential function 2 to the x when the x values are modestly sized. But if we zoom out a little, let the x values get a little bit bigger, and now what I'll do is I'll increase the y values more and more. And we step back and look at what our graph now. The x to the fifth, the purple graph, is still dominating 2 to the x. It doesn't really seem like this red graph has any prayer of catching up to the fast growth of the purple graph. But it turns out that because the red graph is exponential, it will overtake the purple graph. Exponential functions always end up growing more quickly than power functions in the long term. What we're going to need to do is go ahead and let these x values get bigger and bigger. I'm sorry, I'm actually increasing the y values here, but it's more so that we can see what the outputs are starting to look like. You see that now once the outputs get to inputs get to 20, the red graph, it still has lower outputs, smaller outputs than the purple graph, but it's starting to get pretty steep. And it turns out that if we just let ourselves get bigger on the y, we'll see that there is actually, let's see here, I'm going to go down so we can at least see the x values. Probably want to scroll to the right a little bit. And so we can see that here at 22.44, the red and purple graphs intersect. So this power function x to the fifth and the exponential function 2 to the x have the same output size when the inputs are 22.5 about. But after that, once the input values get larger than 22.5, the red graph grows significantly more quickly than the purple graph. So if you wait long enough, if you go down this x-axis long enough, in the long term, exponential will dominate power.